because let's assume that I don't have an email, he has only email. Now he has a different form of communication. Even though we share the same language, we don't have the same connection medium, or we don't have the medium of communication as the same one. Right now, this is a problem because we both need to be on the same medium, speak a common language, so that we can send information from my end to my end to his end. Right now, this is what actually machines need as well, and this is what we say, or these are the fundamentals that we uh, enable in the IoT world using protocols which act as the common language, and we have the various instruments, or we have the various electronic what you can say, controllers or communication devices such as antennas, transmitter receivers, and all of these things. Right, so all of you have heard about Bluetooth, Wi-Fi, maybe some of you have heard of Zigbee. So all of these are communication platforms, right? Communication media, communication languages, so as we can speak, but they need their own transceivers or their own infrastructure to be useful, right? And what do we gain out of this communication is something which is a network of devices which can be which can come together to create, or to create a network which carries out some tasks. For example, if I have a lot of sensors, I can take this data, store it in a database, analyze it, and maybe carry out something. If I so in your case, I guess I'm not fully aware of the event, unfortunately, but I feel that you will be controlling robots from other places, right? So that is that in that case, what you are doing is you are controlling actuators instead of sensors, and so you are causing some effect on a, let's say robot. Let's say I am sitting here in Maharashtra, in Pune, and I want to control a robot in a factory which is in, let's say, Orissa. Then what I'm doing here, is that I'm controlling something using the communication framework laid for me, and I'm able to do this only because of IoT. Okay, so that's enough into what IoT is. We'll deep dive into what is the IoT architecture. Any questions so far? If you have any questions, you can write it in the chat, or you can unmute and directly ask me. It's no problem. You can even add some things, right? So I am just an engineering student, just like all of you guys. So I may skip something, or I may have less knowledge about something that you may have. So it's absolutely fine if you add something as well. Okay. So let's go in a bit deeper into what I mean by IoT architecture or stack, right? So what is the IoT architecture? Now, how many of you know or are aware about the OSI model? Do you know what is the OSI model?
No, sir.
No, please don't call me sir. Yeah, okay, no problem. So OSI is what you can say is a stack or architecture which defines the various layers of services that a smart machine or a communication machine capable of communication should have. Right, so there are so using that we have made the TCP/IP protocol, we have made the IoT architecture stack, and all of these things. Right, so on the left hand side here, I believe you see a system that is an IoT architecture, or that uses IoT architecture. So I just want you to see this system first. So can you understand why this is IoT and what is happening? Any two of you try to just summarize in one sentence or two sentences what is happening in this system. Any of you will be fine. Okay, can anyone unmute, or just should I ask? Okay, so maybe uh, Ritik and maybe somebody else. Aman. Okay, try to summarize what is happening here just in one sentence or two sentences. It first takes sensor data and gives it as output. Yeah. So that is true. That's part of the system's purpose. We here you can see actually that we have a very complex and very good system, which is not only just taking data, analyzing it, storing it in various formats. So first it stores it in a data lake, then in a big data warehouse. All of these things. We have sensor data, we have control applications, all of these things, and you convert, and you also have machine learning models and all of these things acting on that data. And finally, what is the end product you get is is data analytics, as well as Amanpreet rightly said, data visualization or data represent. I can view the data. How I can do that? Via the web application or mobile application, right? So what is the application? So application layer is the more topmost layer. Okay, we'll go downwards. So we go to the root layer. What is the root layer? It is the sensors and actuators layer. The sensors and actuators, as I said, are responsible for either getting data from the real world or send or doing something in the real world. So I always like this analogy. So consider let's say a wizard. Okay, a wizard. Now, what a wizard can do is imagine something that we all can imagine, right? And enact that into reality. Well, I can't, you can't, a wizard can. So I may not be able to make a uh, sofa float, but a wizard may be. Why? Because he and I may imagine the same thing, but he is able to act on it or bring that into reality. Now that is possible because of his wand or some staff or something, which is essentially his actuator, and the spell he is using is maybe the code or maybe the or maybe the logic that I and he are both have it, but I don't have the actuator, he has, right? So that's actuator. So you do something from your data world, you bring something from the data world to the real world, then that's an actuator. So what are types of actuators? Motors, drivers, all of these things. What are sensors? Sensors are something which are like your eyes, your ears, and all of these things, right? They take data from the real world, convert it into data which can be actually stored, read, and operated on by the computers, and store them in servers or data lakes with data warehouses, right? Now, that is the sensors and actuators data. So that's it is responsible for, let's say, in this case, bringing the real data to my system. Now, how many of you are here from electronic systems course, and how many of you are from data science course? Maybe the organizers can also give. Okay, so there seem to be a lot of people from data science. So I won't go into how sensors work. Okay, that's fine. But you guys have DBMS, right? So you should have a basic idea of how data lake and data warehouse and all of these things work. Uh, on the other hand, yes, so some guys are saying they have experience with electronics. So electronics, you know, sampling rates, you know, discretization of sampling rates and data collection, all of these things, right? So we do that use in the sensors and actuators layer. Then we have the networking layer. So actually, according to the protocol or IoT, this is the most important layer because this is what facilitates communication between devices and between systems. And this is the layer where you will have all of the protocols which are enabling data transfer. Okay, data transfer or data reception, all of these things are enabling being enabled because of the protocols and infrastructure in the networking layer. Then you have the data processing layer. Now, a lot of you are from data science, so you are actually designing systems, or you as engineers, if you are operating on this system in particular, then you will be sitting on this layer, the data processing layer, most of you, and the rest of you will be sitting in the application layer. So what is the application layer? Application layer is the layer in which we develop applications for the users. So here, all of this is useless if my end user, who is, let's say in this case, let's say this is data from some car. Okay, uses from some automotive system, and I am providing this data to two or three users. So the owner of the car, the car company, or the maintenance guys, and let's say the third is the running data to maybe some of the data to, let's say, local government authorities, maybe. Just think of that for a second. Now, this system is useless if this data cannot be packaged in a format where all of my users can use it or can view it, right? I may not want all of the users to view all the data, but I want them to interact or provide or view some of the data in some of in a good format. Now that is the application layer. Okay, so this is the IoT architecture or stack. If there are any questions, I'll stop for maybe 2 seconds. You can ask or we'll move on. Okay, so like application layer is like web app or user interface from where they can interact. Yes, but that is a part of the application layer or one of the services that the application layer provides. But there are others as well. So application layer can also involve, as you said, apps and all of these things. They can also involve dashboards, visualizations. Maybe in some cases they can involve. So they can also have, let's say, control or action objective. So, for example, if I have, let's say, I receive some data regarding failure in some part, I want to actually shut off that part, or I want to start a protocol or something which actually takes care of that measure. So, all of these interactivity is also provided by the application. Right. Any other questions? Okay, how data is stored from sensors? So data is actually from sensors. That is actually what I said. So sampling and all of these things, right? So we sample the data. So let's take an example of a temperature sensor or a thermistor. And what it does is it changes resistance values according to the ambient temperature. Now, let's say you have a resistance, or so if you change the resistance, what you're measuring is essentially is the change in voltage or current, right? Let's say you have a change from 5 milliampere to 3 milliampere. So that 2 milliampere is associated with some drop or some unit of the temperature, right? Because I know the thermistor responds in this proportion to temperature change and has this operational range. So let's say that 2 milliampere drop responds to a 2 degree Celsius drop. Now, if I have this data from at that moment or that instant, now let's say I have a digital sensor. So I get this data from my digital pin, and how do I store it? Okay, so how do I store it? Maybe I store it in a CSV format. I just put that all of the data into the CSV format, and at the end of, let's say, 100 iterations, my CSV is then dumped into a real-time database. A real-time database is essentially a database which has a lot of fast input or read-write operation capability. Because in IoT, what you are mostly doing is reading and writing very fast, or very at the rate of 1 second, half a second, 1,000th of a second, or all of these things, right? So that is how the data is stored into the DB. Any other question? Okay.
Hello.
Uh, yeah, yeah,
Yeah, Vikram, I would just like to add to some of the people asking few questions. So
yeah.
the entire architecture. So there is no okay. This is to people who are asking about where it is stored, what is the web app, what is the application front end. So basically, IoT is kind of a framework. Okay, so there is no hard and fast rules about the input and output. Okay, so inputs can be multiple. Maybe you have a huge factory where there are hundreds of nodes, temperature sensor from all of them come. Your front end can be uh, as simple as a mobile application for the owner, or it can be some dashboard on your say manager's room, things like that. So there is nothing hard and fast saying IoT means one web application and one temperature sensor, or one set of sensors and one actuator.
Yes, yes,
So the
I am
front
actually, yes, that's actually absolutely correct. And thank you, Anub, Abhinav, for your input. And yeah, that's really a very good description of the IoT architecture stack. This is just a framework, or this is just the bare minimum, or this is just the fundamental description of what an IoT architecture looks like. As you said, I have recently worked on a similar project, and I'll also go into a bit of detail. Then we can maybe learn all of the or discover all of these aspects in more depth there. Yeah. Okay. So let's go into IoT protocols now. Now, as you saw here, these are the diagram on the right hand side showcases all of the protocols, some of the protocols in that layer. Now, in the application layer, there is HTTP, CoAP, MQTT, all of these various protocols, right? WebSockets, DDS. Then in the transport layer, you have TCP or UDP, all of these protocols. So we'll not go into which protocol is for what application, but instead we'll actually go into what is a protocol, right? A protocol, as I said, is the language with which you have to speak. So an IoT has a set of rules and standards. Now, uh, you must have maybe read about some of the other protocols, such as maybe the the data transfer protocols, such as USB via USB and all other things. So what we have here is actually how should I send the data? Is there a flag or parity bit? All of these things. All of these are the set of rules and standards which define or which are required for communication from on the both sides, transmission and reception. So that is what a protocol means. Now, why do we need protocols? I guess we covered that. That if you want data or if you want anything, any connectivity between two devices, they have to speak the same language on the same platform. That's why we need protocols. Then you have metrics for comparing protocols. Okay. So can any of you just maybe tell me what the metrics for comparing these protocols may mean, or what may be what these metrics may be? Speed resiliency. Yeah. So maybe if I understand it correctly, that's supposed to mean okay. Wait. So Tinku Kumar, I guess you've unmuted, but there seems to be a lot of noise from you. Yeah. So I guess what Abhinav means here is that if I am sending at one speed, let's say a baud rate, then the other guy should also be able to receive it at the same and make sense of the information. My protocol shouldn't collapse or shouldn't be non-decipherable there, right? So that's one of the metric. Other metrics are latency, throughput, energy consumption, computational cost, signaling cost, communication cost, storage cost, and many others. So mostly the cost associated with using that protocol. There is again, as you said, security. So that's another very important method. I don't want, let's say, in some areas, I don't want my data being susceptible to maybe getting hacked or just stolen, or I don't even actually in IoT there is actually a very one of the biggest threat in IoT systems or frameworks is because of phantom devices. Have any of you heard this concept before? Or ghost devices? Okay, so phantom devices actually mean that devices that don't exist. Let's say I have a factory, and in that I have, let's say, 10 machines. And for each of those machines, let's say I have a data port which sends the data, say important data. But in application, I'm actually getting data for 18 machines or even 12 machines, and I am using this data to, let's say, calculate what is my operational efficiency, or what is my throughput of my factory and all of these things, or what is the state of condition of my machine and all of these things. And what I'm getting is data for 12 machines. So that junk or garbage data is actually influencing or uh, just hurting my analysis in a wrong way. So it's not actually stealing my data, rather giving me false data or useless data, which is actually being a hindrance to my analysis or other frameworks, right? So here in IoT, security is from both sides. So security means that he should not be able to send or receive data, have somebody else from outside, right? Now another important factor, which is one of the reasons why we use the MQTT protocol, which I'll go a bit later into, is the QoS, or quality of service, or ensuring data delivery, right? So for example, if I have you ever tried? talking to someone under the water, right? If you're under the water, we know that sound travels actually faster. So in theory, you should be able to communicate, right? If you are sending signal, you should be receiving signal. But how do you know if let's say if a person A and B is talking, and A speaks something, and now B wants to A wants to confirm whether B has received my signal or not, then B has to respond, right? And both of them should hear each other. Now this underwater, this won't be possible. So even though the sound is reaching you, you are not being able to decipher it, and the other person is not able to tell you whether they are receiving the information or not, right? So this is what we call handshaking or handshake in communication terminology, and in MQTT we call it QoS or quality of service. So we'll go into that, but so these are various metrics we have for comparing protocols, and we select which protocol we need according to our use case. So IoT actually relies heavily in IoT. The most important thing is the use case or the app, where we are trying to apply it. So that is a central point we should always remember. Okay, so these are some communication models which I'll go a bit into. So first is the push-pull model, right? In many of these, you have a terminology of a publisher and subscriber or a broker, and in some of those, you have also a client and server. So all of these terminologies are clear to everyone, right? I shouldn't spend time in explaining what client, server, or publisher, subscriber means, right? Yeah. Uh, okay. Even though you have said that, I'll just go into what publisher and subscriber means. Just one sentence. So publisher and subscriber means publisher is just sending data and subscriber is receiving data. Okay, and broker is somebody who just facilitates the traversal or data transfer. Okay. Now in the first model, you have push-pull communication model where publisher sends messages to queue. Now queue, all of you are familiar with the queue data structure or what queue means. Uh, for all of those who don't know, it's a FIFO, right? First in, first out. So if you say queue is kind of like a pipe, right? You send some, you if you're sending some things in a pipe, then the first thing you send will be the first one to get out of the pipe, right? So that's what a queue is. Now we are using queues, right? And these queue or the element in this queue is being pulled by the consumer. So we have a publisher consumer model. Then you have exclusive pair communication model. So this is actually very interesting model. So in this model, what we do is we request. So we have a client and server pair, and we say that now these two things. So this is what we used to call a vivaha terminology. So this man and this woman are now married. Now they will speak to each other, and it is a very good saying that no one else should meddle with the affairs of a wife and husband. So just like that, no one else will meddle in their message in their communication, right? So client, so only these two. So this is a duplex communication. Both can send data and receive data. In the first model, it was a simplex communication. So what is simplex and what is duplex? So duplex is I can send and receive data, and simplex is I can either send or receive data, right? And there is a half duplex half simplex which is also there, which says that you can send or receive the data. Only one of these operations can be carried out at one moment of time, that is half duplex. And uh, the duplex simply means that you can do the both simultaneously, right? So this is the client server exclusive prayer communication model. Then you have publish subscribe communication model. This is the one that is actually used in MQTTs, right? uh, I would actually go into bit of detail in the pub sub model or publish subscribe model, where you have a publisher which and all of these consumers here are actually subscribers, right? So the subscribers are essentially the people who get the data. Now, what? But there is a important terminology here of a broker and a topic and actually a message. So message here or anywhere means data. Now this message can be in many forms. How many of you know JSON format, JavaScript object notation? Yeah. So that is one format in which messages are generally sent or data is generally sent, which is actually a dictionary format, right? So you have let's say I have temperature, vibration, maybe humidity, and let's say other some other sensors. So let's say infrared, maybe, or we can have some other sensor, and all of these will be the keys, and for them the current value will be the value. So this is now packaged into a message, and this message at that for that particular instant or that particular interval is now sent from the publisher. Now this, if you think about it, in a room, let's say, or let's consider our cabinet ministry. So most of them, the problem is that everyone is speaking about every subject at the same moment of time, and that's why nobody is able to make sense out of what is happening in the parliament, right? So that is something that would happen without a broker and topics. So that is why we actually have the moderator. So in Lok Sabha, we have the moderator. Right? Now, so that person who is kind of like the broker. Okay, that person and whole Lok Sabha complex is kind of like the broker. What they do is they allow one or two people to speak at the same one time, send that, or so they are the publisher. Rest everyone is subscriber at that point of time because everyone is listening to what is being said, and the moderator also allows only certain topics to be addressed at the same time. So they are not speaker, somebody who's speaking in the parliament is not supposed to talk about some global problem, local problem, and maybe his family problem. So like maybe his kids don't eat broccoli and all of these things at the same time. He is only supposed to address one topic at a time. Discussion on that topic will lead to some conclusion. Then we move on to for next topic, right? So that topic essentially allows for a segregation of the data in various bins. I guess you all know what bins means. Now, in these topics are mentioned before, so we set up the system or communication. And if you're trying to subscribe or publish to a topic that does not exist, you will receive some error. Now, the topic here means, let's say I am, uh, let's say I have, let's say a data for, we'll go back to the factory example. So I have these 10 machines. Now, what I want is I want the data for these machines, so temperature data of the tool bed or for the machine to be segregated according to the machine itself. So my message for the temperature value will go to the topic. My factory is the main topic. Then there is a subtopic called sensor data. Let's say in that sensor data, I have, let's say, machine one in which I have temperature. So what I'm subscribing to is essentially the machine one temperature top, and my value will go to that topic. Now, if a consumer or a subscriber one is trying to read the temperature or subscribe to the temperature or the data for my machine, what will he do? Or if he will subscribe to the topic that I am publishing, he will be subscribing to the topic factory, sensor data, machine one, temperature. If he is only concerned with the temperature value, if he is concerned with the actually, let's say all of the sensor values for that machine, the topic he will be subscribed to is machine one slash temperature, machine one slash vibration, and all of the other things that you have, right? So machine one is the topic he is actually interested in. If I want everything in the factory, I will be subscribed to factory one, which has all of the children or all of the subtopics included. Okay, so that is the pub sub model. Then you have request response communication model. Just one thing I would like to mention here is that in the pub sub and request response, you have indirect communication. Okay. So in the above two, you have actually kind of a direct communication where two guys are directly talking. This is also called M2M communication, machine to machine communication. Actually, they are not equivalent, but in machine to machine communication, you can have one machine talking with another, and not a lot of machines communicating together. Okay. So in the request response model, you again have a client which sends which has either has a request or response. Request to send request to send data and something, or receive data, anything, and this request is sent to the server. Now this is a server that acts in between. Now this server actually responds to this request, and that is given via the response. And what does it do? So it has a connection with the resources, right? Now what is this resources? So all of you, I guess, are aware about the HTTP protocol, right? So this is actually a request response model where you have a server, let's say request some data. So I guess you have seen these errors, right, from that website not responding or not found on all of these errors. So this is actually us sending a request for some data, and the server either not being there, being shut down. So if yeah, 404 error is most widely known. You also have that server down error which often comes on government websites. So that is essentially the server is down, so it is not responding to your requests. Now if it is not responding to your requests, you cannot get any data, or so you cannot get any resources, because there is no direct connection between you and the resources. Also, there is zero connection between any client one and client two. There is no inter-client connection, to speak. So you cannot talk with anyone there, and the server needs to be up and running. Also, it needs to have the resource, or needs to give you a certain priority where it can give you that resource. And this is actually more widely explored in the web domain, or all of these, where you have a lot of, you have to scale, or you have, the server has to handle the complexity of a lot of clients making a lot of requests at the same time, right? So some of these Geo, Hotstar, and other servers are maybe using very good servers for their scale. Just give me 1 minute. Yeah. Thank you. So let's go into the MQTT protocol. I've already discussed quite a lot regarding how it works. I'll just go into the origin, maybe. That's a nice story. So the origin of the MQTT protocol comes from a use case. Again, so most important things in IoT are the use cases, right? So what was the use case is that there were some oil pipelines in the 1990s, I guess. So people wanted the data from oil pipelines. Now these pipelines were laid in remote areas for a very long regions, or very long pipelines, and it was almost impossible to maybe set up a communication framework to get data from all of the, let's say, controllers or booths on that pipeline. So the only way to get that data was via satellite. Now, I'm sure many of you may have guessed that satellite is a very bad way to get data if I want to have monitoring, because satellite has a lot of latency because it is very far. Also, there is a lot of maybe a noise if I'm sending or receiving some data from a communication device on Earth and in space. Also, it was quite difficult this was quite difficult problem that they had. Now what they did for the MQTT what they devised, or is actually the message queuing telemetry protocol, right? Telemetry transfer protocol, now MQTT protocol. Now what they did is that they created a very lightweight, a very a lightweight protocol. So why is it lightweight? Because the amount of data I'm sending to a satellite should be small. If else I'm going to face a lot of errors. So it was it is very lightweight. It also has QoS that I mentioned. So because of the situation, if I am not sure whether I have received the data, then there is no point in there was no point in locating or trying that communication, right? I should ensure that my data is being transferred, and also it can operate at very poor internet conditions and all of these things, because in their case satellite communicating with something on the ground was and that too not a ground station but with controllers placed on a oil pipeline, was going to be very difficult. Now this protocol was devised for this or what you can say, a very difficult or complex use case, but it turned out that this is very useful for even our normal use cases because of its lightweight, then QoS and all of other capabilities. Okay, so this is the MQTT protocol. Now yeah, so this is how an MQTT protocol system looks like. So this is as you can see here, it connects publishers and subscribers and allows them to communicate with each other, allows them to maybe save and store data, and do all of the things a communication framework should enable it to. So this is a system which shows a humidity sensor. Now this is a smart sensor. What I mean by smart sensor is a sensor that is, or sensor unit that is capable of sending or publishing data over the web. Now, saying is that publish 21%. That is the current humidity. Now, what it is, as I said, what is important, of vital importance, is the topic. So you are publishing 21% under the topic humidity. Now, a humidity controller is a microcontroller device which is, let's say, fitted in your AC. Okay. Now this AC wants to ensure your humidity stays, let's say in this case, stays 15%. Right. Now what will it do? In this case, maybe it will try to dehumidify, because it has, but before it tries to dehumidify, it has to understand or know what is the current sensor data. So it subscribes to the topic humidity. Now you will get to know here that since I'm always publishing or subscribing to a topic, it is not a problem if some of my devices stop working, because if some of my devices stop working or faces a communication delay, I am still, the topic is actually being handled by my MQTT broker and not the device directly. So because of this indirect communication, as long as my broker is running in a very good condition, even though if I, let's say, I have a lapse in the data reception or data publishing, I will not face a very big issue in the which happens in the case of REST API, because there is, you are sending a request and all of these things, right? So in some other protocols you will face an issue, especially in maybe M2M type of scenario, where if the device in front has a delay or just stops working for some time, you will face a very big deal. Instead, here you will maybe get dummy data or something, but the system won't break down completely, and the humidity controller then receives the data, acts on that data, and let's say does what it wants to. Now let's say you also have a temperature sensor. You get the temperature. It is not shown here, but let's consider another device here. Now you get that temperature data, and then you also have a temperature control, which is also, let's say, in your AC. Now what it does is it subscribes to this. Okay, so here it's also subscribing to humidity, but let's say you subscribe to temperature, and then what do you do is, what you then you control the temperature according to the required or set temperature. So this whole system is has sensors, actuators. Maybe you are also storing this data somewhere. So in an AC, it may not be that useful to store the humidity data for the day, but let's say you want the average, let's say, temperature of the building. So many of you may have heard of green buildings or other IoT smart buildings, which store the data, and maybe the system modifications can be done uh, to solve some of the challenges. So if I have, let's say, a server, then that will also be subscribed to the topic temperature, humidity, and all of the other topics, and it will be a passive agent. It will not do anything. It will not publish anything, but it will simply store the it will store the data that I'm getting. Okay, so this is the MQTT MQTT scenario. So going back to the QoS that I said, so QoS or quality of service is a useful uh, service that is provided to us by MQTT, or a feature which actually allows us to check or validate whether data delivery and reception is working. So there are three modes. QoS can be 0, 1, or 2. In 0, it is just blind sending and reception. So the publisher doesn't care whether it's actually the subscriber is receiving or not. You simply just you simply keep sending data, and don't actually care whether it's being received or not, which is actually the level at which most of the other protocols work. Many of other protocols work. Then you have QoS 1, which actually has which actually when your data is sent, you also send a message that data is being sent. So you have a validation of the data sending, and in QoS 2, you have a validation of data reception. So you have a kind of handshake where the receiver says that I have received, and sender said I have sent. Now this enables us to tackle some of the challenge. So even you can imagine in the original case, since they were using they were satellites and all of this costly equipment, they had to ensure the data delivery was actually working fine. Because oil pipeline, let's say in an oil pipeline, if there is a problem, that problem may result into a catastrophic uh, uh, or catastrophe that may not be able to may not be able to handle quite easy because of its remote destination and whole scale. So they had to develop this to ensure that the data was being sent and received correctly. Now we'll go to so I maybe reaching the end of time. So we'll this is just applications of IoT. I'm sure that you must have either heard of these, or during this lecture you must have thought of a lot of applications of IoT. So these are some of the applications that I have listed here. I'm sure. So in your robotics maybe event, you will also so you will be working on an application itself, and I'm sure that it will be very interesting for all of you guys to learn more about the applications of IoT. So there are a lot of these case studies that you can read regarding IoT. One area that I personally love and I have actually uh, worked a bit in is smart city and industry 4.0. So in smart city, I'm sure some of you may actually belong from smart cities. So you have, so you may know what smart city is. It is that it essentially means that you have a lot of this data gathering, and you can also you have this info, data driven decisions and data driven operations in this for the city. And in industry 4.0, I advise you to actually read about it. It's a very interesting thing. So industry 4.0 essentially means that you take all of this machine data, do a lot of analysis on it, devise strategies, or maybe uh, decide some runtime tactics to handle these problems. Then you can it's also efficient for ensuring your error or reducing your error rate, and all of these things. So actually advise you to read about industry 4.0 and some of these other applications. This is another slide that I just wanted to include to show you how use cases are what actually impact IoT architectures or IoT systems. So first is a cellular system, then you have a LAN or local area network system, then you have a LPWAN, low power wide area network, and then you have mesh protocols, right? So I'll not explain a lot, but this is I don't think this is quite clear, but you may be able to read some of the use cases that you see at the bottom. So these are different types of IoT systems. They vary in data rate, range, battery life, and other efficiency, and they have a lot of uh, use cases according to that. Okay. So any questions or we'll stop. So any question or any suggestions that you also require. Okay. Okay. So yeah, yeah, no, yeah, yeah. So I guess I have addressed the 404. So I will go to Amrita Nishu's question. So please explain push pull. I can't grasp on that one. Why it is named as such? Okay. Uh, to push and pull.
Sir,
Yeah.
can you share this PDF?
Yeah. Okay. I'll share it. No worries. Maybe I'll share it to Akhilesh. Maybe you will share it. Yeah.
Okay, I already joined group.
Huh. So, okay. Coming back to the push-pull communication model. So this is similar to what we were doing in the publish subscribe model, but this is direct communication. So what we have here is a queue data structure in which I am sending or pushing data from one side, and now this data has to be accessed or requested from the other side, right? A queue has a characteristic. If I push something, it will go to the front, and then if I let's say I have exceeded the space of my queue and I push something else, then that has to be the topmost value has to be pulled or has to be received by some other agent client. Now this client is the consumer, and this what it's doing is simply indiscriminately pulling the value at the top of the queue. So it can only read that value. It can only read from one queue, and it is simply reading it without doing any without it being specified to being some topic or any other. The main difference is that this is the most basic communication protocol, where you are just sending things indiscriminately and reading things indiscriminately, and that the queue that you are reading from or being sent from is maintained by, let's say, it is actually made before implementation itself, so it cannot be changed or acted a lot upon while in the running state. Does that answer your question? If it does not, actually, I'll advise you to maybe read these concepts from a lot of online resources. There are very good online resources available. I guess some are referenced below the image itself, right? So Internet of Things book.com. So that's where you can read it. So it will like line by line deliver the data. Exactly. Yeah. Sure. That's what. Yeah. Just like the data structure does. So you know about the data structure operation, right? So publisher is simply carrying out the push operation, and the consumer one is only doing the pop or pull operation. So just taking things from the queue. Okay. Any other questions, or we'll stop? Okay. If there are no other questions, I guess we'll stop. I hope you have a very good fest and have a lot of fun in the Robo Race event. And I wish you luck for your future endeavors. You stay in contact. Uh, I'll actually share my contact with you as well. You in contact maybe. You can tell me about the projects you have done. Maybe we can collaborate on some. And I really thank all of you for giving me the opportunity and being a very good and patient audience throughout this session. Thank you. Yes. So thank you, Yantra, for this opportunity, and thank you all for staying with.